Hi, I'm Ibang Sikechi Savior from Kumo National Institute of Technology. I work with the Network System Lab. I want to present the concept of using Internet of Things for cost-effective railway maintenance. These are the contents of what we'll cover in the slides. We already know railway is one of the major means of transportation, but the maintenance of these railways is still a problem for the operators. So we try to make a proposed idea that will reduce the cost of maintaining the system and yet will be very efficient. There are two methods of scheduling maintenance. We have the periodic and have the condition based. Now in the periodic there is a fixed time to maintain the railway, say 6 months, 1 year, 3 months, as the case may be. But in condition based maintenance, it involves the conducting of maintenance at any particular equipment at the point when its performance has slightly deteriorated and needs replacement or maintenance. Now, this will allow all the equipment in the infrastructure to be used to their maximum time before replaced. But in the periodic method, some equipments will have to be removed before they are fully used, just to make sure that the system is working fine. But you all know that will cost more money. Okay, just to give a fair idea of how maintenance and what it costs in Korea looks like. This is about the amount spent in general maintenance in 2009. This is for the high speed, and this is the sum of what is spent in 1 year. And this is the detailed explanation of how the money is spent for 1 year in general railways. Now, using the IoT is a new method, and the old method is the conventional method, which usually is about 2 times in a year, but this one promises to give an up-to-date condition of the railways on a daily basis. And in the conventional method, it needs a lot of human effort, but in this proposed method, there will be sensors doing the work. So, as we know that using a lot of human effort will result to huge expenses, but the cost will be reduced if sensors are used, and the hazard of going into the railway will be removed if sensors are doing the work. So it's safer to use this proposed method. Then we have the results. It shows that conventional methods are kind of inefficient, while the IoT method is more efficient. Okay, now if we come to the IoT method, there are two possible means of applying the IoT for maintenance. You have the mobile method, using kind of mobile sync and using a static relay. Now, in the use of mobile sync, this is where we have our interest. This is what we'll try to work on. The mobile sync will be such that the train will be the mobile sync, but in this static means there will be infrastructures mounted along the side of the railway to transmit information. You know that these equipment that are always running to be able to transmit informations will require power supply and things like that. So it's going to cost a lot of money to run the communication system, and also the cost of installing the equipment will also be high. Then you have the transfer speed. It's going to promise going to give a very fast or faster means of transmitting the information, But the mobile sync will still not be so bad because it will be bringing information on a daily basis, which may not be too late. Which brings us to energy consumption. Because this one is constantly running, it will require more energy. But because the train is just moving and picking up the signals, it will reduce the cost. Now, in our proposed method, we are going to require sensors, gateways, trains for mobile sync, and then the base station where the decision will be made. This is the architecture. Sensors will pick the data and move it to the gateway. The gateway moves to the train, and the moving train carries the information to the base station where the decision is made. This is just showing the arrangement. The sensors are positioned, these sensors connect to the gateway, and these gateways gather informations from the sensors and set it ready for the moving train. As the train is coming, they transmit all the data to the train, and the train goes ahead with it to the base station where it offloads all the data gathered while it was moving. And this maintenance or condition of the railway will be used to make decision to guarantee safety of the railway system. So in this our work, we have investigated the major challenges and opportunities associated with smart railway infrastructure, and how IoT based maintenance methodology using mobile sync can be actualized. And also, in this method, if adopted, is going to be a fast track to the implementation of IoT in railway maintenance. In the future work of this paper, we are going to find a suitable network technology that will guarantee smooth real life application. Thank you.